At 1332, Chapter 7, Consumer Mathematics, Section 6, Mortgages, Video 3, Amortization Schedules. Now, what the heck do I mean by that? Well, when you buy something or borrow money and pay it off over time, well, I got it on the next page. When you make a payment on any loan, a mortgage, a credit card, a car payment, whatever, the amount you send each payment is split into two parts. Part number one, the part that pays off the interest earned during that pay period. Because as you owe the bank money, the interest clock is running. And every time you make a payment, they say, we're going to take out our interest first. And the second part of the payment is the part that pays down the amount you still owe. In other words, the part that lowers your principal. Now, by law, whenever a bank issues a mortgage, the bank is required to make available a schedule that shows how each payment is split between interest and principal. And this is called an amortization schedule. Now, they don't always put it out in front of you, but if you ask, they have to provide it for you. Now, to create an amortization schedule, you have to ask yourself the following questions for each payment made. Question number one, what is my current balance owed? This question is important because the amount of interest that you're going to earn during the pay period depends upon how much you still owe. Number two, how much interest is earned during the pay period? Now, just as a note, the per period interest is calculated as simple interest, I equals PRT. You'll see that when we calculate it here in a moment. And this is on a per payment period basis. So if your payments are made monthly, then each month your interest is calculated using simple interest formula. Number three, how much is left from my payment after the interest is paid? The bank gets their part first, then the rest goes down towards what you owe. And then fourth and final, what is my new balance owed after I apply the remaining payment amount? So in other words, when you send a payment, the bank says, first, let's figure out how much interest you owe us during that month. They take that off the payment, put it in their bank, if you will, and they say the rest of this is going to pay down what you owe. Now, what happens in the short term is at the beginning, a huge chunk of your payment goes towards the interest, which means a small part goes towards the balance. So you could send in, say, $1,000 payment, and then your balance might only go down $150. This can be very discouraging. But at the end of this video, I'll show you that it turns around towards the end. All right, creating an amortization schedule is straightforward. However, it involves many calculations. The trick to creating an amortization schedule is to stay focused on the four previous questions. What is my current balance owed? How much interest is earned during that pay period? How much is left from my payment after the interest is paid? And what is my new balance owed after I apply the remaining payment amount? The results are going to be summarized in what's called an amortization schedule, and the table will look like this. You'll have a column that represents which payment number you are. This is usually the month that you're into the loan. So what you see here is first month, second month, third month. The second column is going to represent how much interest was accumulated during that time period. Now, each time period will be the same. During the first payment, 1 month has elapsed. During the second payment, 1 more month has elapsed. During the third payment, 1 more month has elapsed. I understand that after the third payment, 3 total months have elapsed, but between payments is only 1 month, 1 payment period. Once we figure out the interest, we're going to subtract that from our payment amount to figure out what's left from our payment, and that will be the payment that is applied to the principal. And then that amount is going to be subtracted from what we currently owe to give us a new balance of the loan. So again, it's a lot of simple calculations, but it's a lot of calculations. Stay focused, one step at a time, and we're good to go. Let's take a look at an example. And by the way, let me back up for a second. What you see here is not the complete table. There would have to be 1 row for every payment. So for example, if you had a 30-year mortgage and made monthly payments, 12 months in a year times 30 is 360. Yes, this table would have 360 rows. No, I'm not going to ask you to complete 360 rows. I will only ask you to complete the first 3, and then I'll show you how you can use technology like Excel to find all of them. Let's take a look at an example. The smaller font size was to fit everything on the screen. A house sells for $472,500 and a 4% down payment is made. Here we go again with the down payments. A mortgage is secured at 5% for 40 years. Compute an amortization schedule for the first 3 months. Round your answer to 2 decimal places if necessary. And oh, by the way, the value of the mortgage is $453,600 and the monthly payment is $2,186.35. In previous videos, we would have had to calculate both of those things. We would have to calculate the down payment and subtract it from the cost to get the mortgage amount, and then cram everything into the mortgage payment formula to get the payment. But on these amortization problems, the focus is not what's the mortgage, what's the monthly payment. It's what happens with that monthly payment. So on the homework problems that ask you to do this, you are given the value of the mortgage and the monthly payment. All right, so let's figure out what happens in the first month by answering the 4 questions. The first question that we answer is, what is my current balance owed? Let me bring this back up to 36-point font. Right now, the current balance that I owe before I make that first monthly payment is actually the mortgage itself. I still owe $453,600. Okay. Now, for the interest earned, we use the simple interest formula, which is PRT. The P is what my balance currently is. So the P is going to be $453,600. The R is going to be the interest rate, which is 5%, which is a decimal of 0.05. But what are we going to use for time? Well, if you go all the way back to the beginning of this chapter, you'll remember that in this formula, the time was usually the time in years. But in an amortization schedule problem, the time has to reflect how long one pay period is, which in this case is 1 month. Well, how are we going to put in the number of years when the pay period is only 1 month? And the answer is 1 month is 1/12 of a year. So one thing you'll notice about these is that we use T equals 1/12 for monthly payments. We use T equals 1/12 for monthly payments because each month represents 1/12 of a year. And that will be the same for any time you're doing an amortization schedule with monthly payments and you're calculating the interest per time period. If it were a different scenario, like we made 2 payments a year, then it would be 1/2 because 2 payments a year means each 6 months is half of a year. All right, so for the first month's payment, our principal is $453,600. That's what we still owe. Our interest rate is a decimal of 0.05, and our time is 1/12. Now, you could turn 1/12 into a decimal and then insert it into the formula, but you're probably going to put it in a calculator anyway, so you might as well just put it all in at once. All right. Now, I could have used X's for times. It doesn't really matter. To be consistent with how I did it in previous videos, we'll do this. But things in parentheses next to each other always mean multiply as well. All right, so 453,600 times 0.05 times 1 divided by 12, because the fraction is just a division problem, to the nearest cent, well, it actually comes out to be a whole dollar number amount, $1,890 exactly. So what does this mean? This means during the first month of this mortgage, this is how much interest I owe. This is what the bank's going to take out of my payment, which brings us to the third part. The payment on principal. In other words, how much we have left after the interest is paid is my monthly payment, $2,186.35, minus the interest that the bank is going to take first, $1,890.00. 2186.35 minus 1,890 is a whopping $296.35. $296.35. I just sent a payment for $2,186.35. Only $296.35 of it is going towards my balance, which means my balance on the loan, so my new balance, is what I owed before I made the payment, $453,600, minus the payment on principal, a paltry $296.35. And now I owe only $453,303.65. Let this sink in for a second. You got into this mortgage. Your monthly payment is over $2,000 a month. And you send that first payment. I send the bank this. Before I sent it, I owed that. After I sent it, I owe this. This is a shock to a lot of people. I sent over $2,000. My balance didn't even go down $300. What the heck? Well, here's what the heck. I'm the bank. I loaned you $453,600. You're taking 40 years to pay it off. Yeah, you're going to pay some interest. And I'm going to get my interest up front because I'm the one taking the risk loaning all this money. So yes, it hurts up front when you send that first payment and you barely see the balance go down. Now, this is the same for car payments, credit cards, et cetera, et cetera. Interest always gets paid first, and whatever's left lowers the amount that you owe. So it stings at first, but I'm going to show you what happens towards the end. Now let's do the second month. Now, how do we do the second month? Well, we do it the same way we do the first month. The main difference is on the first step, the current balance is not the original mortgage amount, but how much was left at the end of the previous month, which in this case was $453,303.65. Now, what ripple effect is this going to have? Well, when we go to calculate the interest, it's still going to be PRT, but the amount that we owe now is less than it was before. Not by a whole lot, but it's less than it was before. Our interest rate is still 5%, so 0.05, and it's still times 1/12 because we're looking at a 1-month period, and 1 month is 1/12 of a year. But because the principal was a little bit lower, that means that my interest is going to be a little bit lower. Is it going to be noticeably lower? Well, you tell me. On the second month, my interest is $1,888.77 to the nearest penny, to the nearest cent. In the first month, my interest was $1,890. So notice that my interest went down by $1.23, but it went down, so it's got some promise. And what that means is that my payment on principal is going to be higher. Why? Because my payment is still the same. My payment, I forgot what it is $2,186.35. $2,186.35. But now the amount that I'm taking away for interest is a little bit less than it was before, $1,888.77. And what is that going to leave to pay off my balance? $2,186.35 minus $1,888.77 is $297.58. Still a very small part of my payment, but if you compare it to the payment on principal in the first month, $296.35, okay, it's a little bit higher. So what's my new balance on my loan? Well, it's what I used to owe minus the payment on principal. And what I used to owe at the beginning of this pay period is not the mortgage amount, but that new one after the first payment. And now I'm going to take away the amount that's left after the bank takes out their interest. And that is going to give me $453,303.65 minus $297.58. And now I only owe $453,006.07. And even at this point, when you compare what you're paying up top and what you started out owing, I started out owing $453,600. I made two payments totaling over $4,300, and my balance hasn't even gone down $600. It is very frustrating up front. Let's go ahead and do it one more time for the third month, and I'm going to cheat. I'm going to go in here and copy all this. And for the third month, and this will be the last one that we do manually, we're just going to put all that in and make the changes as necessary. So I'm going to be going back and forth between this one and the previous one. Let's start with the current balance. At the end of the second month, our balance on the loan, our new balance was $453,006.07. So let's put that here. And that's going to go into our new interest calculation. So lower principal means lower interest. Let's see what this interest is. That number times 0.05 times 1 divided by 12 to the nearest cent is $1,887.53. Okay, so this is the interest that the bank's going to take out. And so that number goes here. And now let's see what our new payment on principal is. $2,186.35 minus $1,887.53 is $298.82. And again, if we compare this to the previous payments on principal going back to month one, our first payment on principal was $296 and some change. Our second one was $297 and some change. Our third is $298 and some change. It almost hit $299. So it is slowly increasing, emphasis on slowly, which means, let's make sure all the numbers are correct. First off, this is my current balance at the beginning of the third month. So that goes here. This is how much it's going down by, because that's my payment on principal. And now let's see what we owe. After we take $453,006.07 and subtract $298.82, we get $452,000. So finally the thousands place went down, $707.25. Still a very slow crawl. And we can summarize all that in a table like this. I'm going to have to go back and forth to see these values, and I'm going to write them in manually. But on month one, and to help this, what I'm going to do is I'm going to actually take pictures of each page so I don't have to scroll back and forth. This will make it a little bit easier to fill in that last page. Okay. And you're thinking, don't you have all this stuff figured out in advance? No, I don't, because I want you to watch the process. I don't want you to just look at notes. You can look at notes statically online. I like my videos to be a little bit more dynamic, if you will. And I'm going to type these in. I think I can jump in a text box here, make it wide enough, and we'll bring the font size back down to 24. And I think I can just type and hit return to get these values in. All right, so starting with the first month, the interest on the first month was $296.38. And so the payment on the principal for the first, excuse me, that was not the interest. That was the payment on the principal. Like I said, that was kind of low. The interest in the first month was $1,890.00. The payment on principal was the $296.35. And after I paid that, I was left with $453,303.65. Then in the second month, the interest that was earned was a little bit less, $1,888.77. The payment on principal was a little bit higher, $297.58. And then the balance on the loan after I paid that was $453,006.07. And then in the third month, the third payment, the interest that was earned was $1,887.53. The payment on the principal was $298.82. And then the balance of the loan after that was $452,707.25. So this is what the first three rows of the amortization schedule would look like. It's depressing at the beginning because you're sending this $2,100 plus payment, and a huge chunk of it is going towards the interest. Very little is going towards your balance, so your balance is dropping slowly. However, you'll notice a trend. The interest is getting lower, which means the payment on principal is getting higher, which means the balance is dropping faster. This is all you're going to be required to do on your homework and possibly a test. However, I want to show you the end result, because what I created a spreadsheet in an Excel. I'll be happy to share this with you. Just ask and I'll throw it on Canvas. That will take in all the values that you need to know. The mortgage, which I'm going to highlight as I say these things, which you'll notice I already have entered. And remember, the mortgage isn't the cost of the house. It's the amount you borrow after the down payment. The term, which in this case was 40 years, the interest rate, and the monthly payment. And if you put all that in, I've already got it set up to do the exact things that we just did. And if you compare, you'll see that the first three rows of the amortization schedule in the spreadsheet exactly match the first three rows of the amortization schedule that we did by hand. The difference is in the spreadsheet, it is manually doing the, it is automatically doing the calculations. I've got a formula here, you can see it up here, that calculates the interest paid based on where you are in the formula. I've got a formula here that calculates the payment on principal, and I got a formula here that calculates the new balance. And that formula is replicated row per row. And if you notice, I did some rounds here. This first one it did say round. Okay. Because when we do this, we round everything down. Now, what you don't see is that I can scroll down to as many months as I want. So this is at the beginning of the amortization schedule. Lots of interest, not much payment on principal, balance is dropping slowly. Let's go halfway through the term. It's 40-year term, so halfway is 20 years. This is in months. 20 times 12 is 240. So we're going to zip down to payment number 240, and we'll see where we are at that point. Okay, when we get down to payment 240, went too far, overshot it. Here we go. Notice that our interest is still kind of high, but it's not nearly as high as it used to be. Our interest is down to $1,385.80 as opposed to $1,800 plus, making our payment on principal noticeably larger. But even halfway through, more than half the money is going towards interest. And at this point, we're down to $331,000. So after half the mortgage, we still owe more than after half the term, we still owe way more than half the mortgage. The mortgage was $453,600. Half of that is $226,800, but we still owe $331,000. So it can seem a little bit frustrating that I'm halfway through this mortgage and I still owe this much. But watch what happens towards the end. And you might be able to witness this as I scroll, that the interest paid is not only dropping, but it's dropping at a faster rate. It's like somebody stepping on the gas pedal. It's kind of hard to see, but notice that the principal is going up and the balance is going down. And as you get towards the end of the mortgage, let's go into year 39. So 40 years would be 480 payments. So let's back that up by 12. So 468. Let's go to the 39th year, 468. You notice the interest is now getting much smaller. The payment on the principal is much larger, and the balance is dropping in chunks now. By the time we get to the second to last year, payment 468, there's hardly any interest at all. Most of our payment is going towards our balance, and we're down to 26,000. And in that last year, it just drops. Boom, 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 boom. And what happens on the last payment? Let's get to row 480. Now, this is not an exact science because of rounding issues. So sometimes when you get to the last payment, it doesn't quite finish the job. And I'll be honest, I'm a little surprised that this was the monthly payment amount that they gave us. And the reason I'm surprised is that's not what you would get with the formula. I have the formula for monthly payments sitting right here. So I'm going to drag it and drop it over here. If you were to calculate the monthly payment using the actual formula, why is it not showing? The monthly payment using the monthly payment formula was actually $2,187.25. The one that they gave us in the problem, for some reason I can't figure out, was $2,186.35. So 2186.35 is what they gave in the problem, and I still can't figure out why. Here's the problem in case you want to see it right there. But if you use the mortgage payment formula, it's actually 90 cents higher. Now, does 90 cents make a huge difference? Well, notice now when I changed it to the actual mortgage payment, and again, I don't know why the website gave a slightly lower value, but notice now in the last month, when I make my payment, I actually pay too much. So what happens on an amortization schedule is they adjust the last payment to zero out the balance. So the last payment here would actually be the new balance plus the interest, which is $9.62 less than my actual payment. Excuse me. But if I were to put back the monthly payment that they gave us, it's Control Z, then at 480 months, I'm getting there. I'm getting there. After the 480th payment, I still actually owe $1,364.21. That's a 90-cent difference that causes a $1,300 difference in the last payment. So what can you learn from this? Even the slightest bit extra, I want to say 35. No, it was 25. Even the slightest bit extra can make a huge difference. To illustrate this, let's suppose that I just send 2,200 a month because that's a nice round number. If I change this monthly payment to 2,200, how quickly will we get out of this mortgage? That's only $12.75 more a month. Well, it's not going to take me 480 months. Let's go back until the balance zeroes out, 471 months. So it shaves about 9 months off. 472 is when the balance goes negative. In Excel, parentheses around a number can be negative. So if I sent an extra, what was it, $12 a month, I get out of this mortgage 8 months earlier. Well, that's not much. But, you know, when you get towards the end, you're like, hey, I'm out 8 months earlier. What if instead of 2,200, I paid 2,500? Okay, now we're talking. Now we can get out of the mortgage. We're almost there. Now we can get out of the mortgage. Okay, it's way up here. Wow. In 340 months, that's not even 30 years. So let that sink in for a second. If your mortgage payment was this, it's going to take you 40 years. If you could afford to bump it up a little bit more, you can shave off 8 months. Bump it up 300 more. Now you're taking off 10 years of payments. And we haven't even talked about what's the total interest that we're paying. We could figure that out by simply multiplying the number of payments times the monthly payment. Like on this one, if we get out of it in 339 months, the 340, because after 339 we still have a balance. If we got out of 340 months, even if it were 340 times 2,500 is 850,000. But if we took actually 40 years to do this with the monthly payment that they give us, $2,187.25 times 40 years is 480 payments is $1,049,880. So what does all this mean? In this mortgage, if you had a monthly mortgage payment of $2,187.25, but could afford to send 2,500, excuse me, then you would save in the long run almost $200,000. when you start a mortgage, if you start a mortgage, it is worth your time to play the what if game. What if I sent more money? What if I had a lower interest rate? What if, well, shoot, what if I did have a lower interest rate? Let's take this back to the regular monthly payment. What if instead of, and make sure that's the one that I actually use the formula for. It's not, give me the formula payment, give me the formula payment, give me the formula payment. Where's the formula payment? Okay, I lost my formula payment. There it is. Okay, 1 second, folks. All right, if we actually use the correct formula payment, because the one they gave us wasn't. And what if instead of a 5% interest rate, you could find a 4.75% interest rate? Watch the monthly payment. You watching it? It drops some, not a whole lot. But what if you could find, let's take it back to 5%. What if you could find 4.5% interest? Okay, better. But what would happen if we said, no, let's do it in 30 years instead of 40? What do you think is going to happen to the payment? It should go up, but you get out in 30 years. What if you're like, maybe 45 years is good? Oops, wrong place. Maybe 45 years is good. Okay, payment's down $2,113.85. No, what if it were 40 years and 5%, but I made a bigger down payment? What if I made a down payment that brought it down to 425,000? Okay, now my payment is closer to 2,000. You can play all sorts of games. And if you want this spreadsheet, I can throw it in Canvas for you. But there are amortization schedule calculators all over the internet. But if you ever get into a loan, credit card, mortgage, whatever, you can use something like this to fiddle around with. What if I send this much? What if the interest rate is that? What if I try to pay it out over X amount of time, and really find a way that maximizes the amount of money that you can keep in the short term and minimizes the amount of money that you pay in the long term. I talked a lot more about this spreadsheet than I intended to. Hopefully, if you hung around and watched all of it, it was worth your while.